In this episode, we dwell on crucial information and tips specifically for international climate change negotiators. We start with the misconceptions on the dynamics of climate change some negotiators have, even as they debate the issue at the global level. Number one, many negotiators assume that once we stop making greenhouse gas emissions, the CO2 will be drawn out of the air, the old equilibrium will be re-established, and the climate of the planet will go back to the way it used to be. This is incorrect. Number two, some negotiators believe that the climate system is going to send more warming our way, no matter what we choose to do. This is also incorrect. The inertia is not in the physics of the climate system, but rather in the human economy over which we have control. Number three, some negotiators do not quite understand that greenhouse gas emissions have the same impact on the atmosphere, whether they originate in Washington, London, or Beijing, or indeed whether they originate in Sydney, Johannesburg, Rio de Janeiro, or Santiago. Consequently, action by one country to reduce emissions will do little to slow global warming unless other countries act as well. Ultimately, an effective strategy will require commitments and action by all the major emitting countries. At Environ Campus, our goal is to promote and encourage better understanding on the part of climate change negotiators regarding the dynamics of the climate change by availing appropriate information. This augurs well for an efficient and effective international climate change debate. In addition to these misconceptions, mankind also has to contend with the fact that in attempting to mitigate climate change, we are faced with the equity conundrum, which arises as a result of the following. Number one, there is a time lag of about 40 years between the emissions gust of greenhouse gases and the global warming that the particular gust is responsible for. The result is that most of the global warming the planet is experiencing right now is as a result of the industrialization of developed countries. In fact, this is since the Industrial Revolution, when it was believed that anyone could spew any amount of emissions into the atmosphere without limit. Number two, the average per capita CO2 emissions for developed countries is currently around 9 metric tons, while that for developing countries is only about 0.8 metric tons. The desirable global per capita is about 1.2 metric tons. Number three, the developing countries are now responsible for 63% of global carbon emissions. Number four, we now know that the dumping space for emissions is finite and is quickly filling up. How then do these two groups of countries equitably share what's left of the space to dump GHG emissions? This is the equity conundrum. There is a plausible solution to this equity issue, as illustrated in the following sketch, which was first discussed under the section on equity and social issues in a 1998 publication by Yepma and Munasinge that is titled Climate Change Policy. The sketch depicts the effort that both the developed and the developing countries have to make in order to achieve the desirable average emissions of CO2 of 1.2 metric tons per capita in an equitable manner. The sketch has two axes. The y-axis shows the CO2 emissions per capita in metric tons, while the x-axis shows time in years. The sketch also shows three curves. The green straight line represents the desirable global CO2 emissions per capita that would keep the rise in the median temperature of the Earth below 1.5 degrees Celsius by 2100. The red curve represents the trajectory that the per capita emissions of the developed countries has to follow in order to be progressively reduced from the current average of 9 metric tons to 1.2 metric tons per capita. The yellow curve shows the desirable trajectory that the developing countries' average per capita emissions should follow. This would require the developing countries to stay below the desired 1.2 metric tons per capita, rather than letting this to explode to the current developed countries' average of 9.0 metric tons. Apart from ensuring that the developing countries stay below the desirable emissions rate, this solution allows the developing countries some headroom to develop their industries, being that most of them are starting from scratch and currently, to some extent, still have to use some kind of fossil fuels. The debate would then be among the developing countries as to how much of the headroom implied by the yellow curve should be allocated to the heavy GHG emitters like India and China, and how much for the rest. An organization called Warmheartworldwide gives a list of many authors that have written on why progress towards a meaningful climate change treaty has been so difficult, slow, and ultimately disappointing. This list is provided in the description to this video. Anyhow, let's look at what humanity has done to manage climate change. The UNFCCC was launched at the 1992 Rio Earth Summit to achieve greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. More concerted effort has been taken through the signature and implementation of the Kyoto Protocol and its sequel, the Paris Agreement. It would be interesting, in fact, to see whether the allocations of the commitments under the Paris Agreement even remotely resemble the model we just looked at or not. However, in general, the results have so far fallen short. Indications are, in fact, that even with the measures in place so far, the planet is set to overshoot the desirable target of keeping the median temperature increase of the planet below 1.5 degrees Celsius by 2100. This is where the following 3 carbon capture and storage technologies might come in handy. Number 1, bioenergy, carbon capture and storage. Number 2, direct air capture of the CO2. Number 3, pyrogenic carbon capture and storage, which as of 2018 has been recognized by the IPCC as a negative emissions technology. This is the use of biochar technology to capture carbon naturally and store it permanently in the soil, a process which also simultaneously enhances soil fertility and thereby also augments agronomic output. We at Environ Campus are enthusiastic promoters of pyrogenic carbon capture and storage technology, and we will dwell on the details of this technology in future episodes. If you have not yet subscribed to Environ Campus, please go ahead and do so now. Also, if you like this particular video, please give us a thumbs up.